Section 5.3, conditional probability and the multiplication rule. Objectives are, so for tonight, we will learn about how to compute conditional probabilities, compute the probabilities by using general multiplication rule, and then using the multiplication rule with independent events. And also the last is compute the probability that an event occurs at least once.
Thanks for getting the lunch to the meals today.
All right, conditional probability. So let's start with this example here. Approximately 15% of adult men in the US are more than 6 feet tall. So therefore, if a man is selected at random, the probability that he is more than 6 feet tall is 15% or 0.15. So now assume that you learned that the selected man is a professional basketball player. With this extra information, the probability that the man is more than 6 feet tall becomes much greater than 15%. So a probability that is computed with the knowledge of additional information is called the conditional probability. So if you need to copy that definition of conditional probability, copy now. A probability that is computed with the knowledge of additional information is called the conditional probability. Okay, the conditional probability of an event B given an event A is denoted probability of B given A, and that is a probability that B occurs under the assumption that A occurs. And the formula, copy this, probability of B given A is equal to the probability of A and B all over the probability of A. All right, so example here, consider the following table which presents the number of US men and women in millions at 25 years old and older who attained various levels of education. So men and women, we have not a high school graduate, 14 men, women 13.7, high school graduate, some college no degree, associate's degree, bachelor's degree, and advanced degree. Then a person is selected at random. Now we're going to answer, what is the probability that a person is a man?
Add up all the men.
Yes, that's correct. And if you add all the men, that is 14.0 plus 29.6 plus 15.6 plus 7.2 plus 17.5 plus 10.1. What is the total number of men?
94.0.
Yes, 94. And how do we answer the first question? What is the probability that the person is a man?
So add up all the total men and women, and then men over women.
Yes, very good. So you mentioned that the total number of men, you said 94.0. out of the total, you get a total of men and women, which is
195.
195. So when you divide this, that's going to be equal to
94.
94 divided by 195.
0.48.
Let's have 4 decimals.
0.4821.
482. Okay, very good. Questions? So that's like a basic property of probability, right? So we did this last time. How about this? The next one. What is the probability that the person is a man with a bachelor's degree? A man with a bachelor's degree.
So the probability that is a man plus the probability they've got a bachelor's degree minus the man with the bachelor's degree union.
Say that again.
So the probability that it's a man, all men, so the calculation we just got for probability of man being a man, and then plus the probability of having a bachelor's degree, so 17.5 plus 19.2, minus the union of being a man and a bachelor's degree, which is 17.5.
Remember, this is not addition, because you don't see the or part, right? So that's one thing. To use that probability of an event A plus a probability of event B minus the probability of the intersection of events A and B. This is when it is probability of A or probability of B, right? But this example, look at the question. What is the probability that person is a man with a bachelor's degree? So that's why we cannot use this. So what you're going to do is, so just look for man with a bachelor's degree. 17.5. So that is 17.5 out of the grand total.
195.0.
So 195.0. So divide this.
.0897.
Thank you. Okay, so probability of man with a bachelor's degree. So based on the table, we have here a column for bachelor's degree men, that is 17.5 out of the grand total 195, and that is equal to 0.0897. Okay, next one is this time it is a conditional probability, and this is what 5.3 all about. So what is the probability that a person has a bachelor's degree given that he is a man? So probability that the person has a bachelor's degree So given that, so this line here, that is for a conditional probability, meaning given that he is a man. So to answer this, so a person has a bachelor's degree given that he is a man. So meaning this is going to be the probability of a man with a bachelor's degree. Over the probability that he is a man. So we got these answers earlier. The first one probably that he is a man, and the second probably that he's a man with a bachelor's degree. Remember that? A and B. So we got this man with a bachelor's degree, 17.5 over 195.0. Probably that he's a man. The total of men, 94.0 over 195. And here, since they're both you're both dividing it by 195, so you just cross out 195. This is just simply 17.5 over 94. So divide those two.
0.1862.
0.1862. Okay, thank you. Copy? So take note of this. Whenever you see this type of example, you will always see something like this. This is the hint, given that. And given that event, your event here is going to be your denominator, always. Okay? So given that he is a man, that's going to be your denominator. And the other event is going to be bachelor's degree and at the same time a man. So that is, you'll see later that that is also part of multiplication. So a man with a bachelor's, combination of the two. So that's why you have 17.5 here, a man with a bachelor's degree. It's like based on the table, man with a bachelor's degree, you have 17.5. And probability of man, the denominator is the total, which is 94. So 17.5 divided by 94 is 0.1862. Okay? Any questions? Oops, there is a chat. All right, next objective, compute probabilities by using the general multiplication rule. And I want you to copy this. For two events, A and B, so probability of A and B is equal to the probability of A times probability of B given A, or probability of B times probability of A given B. So you learned about conditional probability. So multiplication, that is and, addition, that is or. So remember, An example here. Among those who apply for a particular job, the probability of being granted an interview is 0.1. Among those interviewed, the probability of being offered a job is 25%. Find the probability that an applicant is offered a job. So solution here, an explanation. Being offered a job involves two events. So first, you must be interviewed. Then given that you have been interviewed, you must offered a job. So those are the two events, interviewed and being offered the job. So to get the probability offered the job is first, you need to get be interviewed times the probability you offered the job given that you were interviewed. So we have here given probability interviewed that is 0.1 and being offered the job is 0.25. So when you multiply the two, it is equal to 0.025. The next one, independent events, dependent and independent events. For addition rule, if you remember, we discussed about mutually exclusive events and non-mutually exclusive events. For this, you will see independent and dependent. So what's the difference between the two? So copy this. So two events are independent if the occurrence of one does not affect the probability that the other event occurs. If two events are not independent, we say, of course, they are dependent. An example here. A college student is chosen at random. The events are being a freshman and being less than 20 years old. These two events are not independent. Mostly, if a student is a freshman, the probability that a student is less than 20 years old is greater than for a student who is not a freshman. How about this? A college student is chosen at random. The events are born on a Sunday and the other one taking a statistics class. Are they dependent or independent events? Yes, these events are independent because if a student was born on a Sunday, this has no effect on the probability the student takes a statistics class. Okay, so since we talk about independent events, so if those two events are independent, then we have a formula here. It's just simply equal to probability of A times probability of B. So you just have to multiply those two. Please copy that. An example here. According to recent figures from the US Census Bureau, the percentage of people under the age of 18 was 23.5% in New York City, 25.8% in Chicago, and 26% in LA. If one person is selected from each city, what is the probability that all of them are under 18? And is this an unusual event? How do we check if it's an unusual event again?
If it's less than 0.05.
Very good. If it's less than 5%. So let's answer first the probability. What is the probability that all of them are under 18?
Just multiply them all together.
What's that?
0.235 times 0.25.8 times 0.6260.
Yes.
So they are independent.
Yes. So probability that from New York and probability from Chicago and LA. So that is probability. So yes, they are all independent. So New York, 23.5%. Don't forget to change it in decimals. So 0.235. So all you have to do is move the decimal 2 places to the left. So that's why it's 0.235 times Chicago 25.8. So that's 0.258. And LA 26%. So that is 0.26. And if you multiply all this, is equal to
0.0158.
0.0158. Thank you. So is this an unusual event? 0.0158.
Yes.
Yes. Because this is like 1.58%, right? So it's less than 5%. Questions? I guess no questions. Then the last part, sampling with and without replacement. So just take note of this. When sampling with replacement, the draws are independent. Without replacement, that is not independent. Oops, there's no example here. I'll give you a good example about with and without replacement. There's no blank. Okay, before we talk about objective 4, I'll give you an example here with and without replacement. So think about you have a box with 10 marbles, and out of 10, you have 1, 2, 3, 4, 5, 6, 7 blue marbles. And there are 3 red marbles. So number 1, find the probability So find the probability that the first pick is a blue marble and the second is a red with replacement. So blue and red. So we want to get the probability of blue and red with replacement. So take note of that. So to answer this, so first probability of blue. So what is the probability of blue here?
7 out of 10. Point
7. Very good. Because 7, there's a total 7 blue marbles out of the total 7 out of 10 times. So let's say you pick the first blue with replacement, so meaning you return the blue marble. Next is you need to pick a red marble. So what is the probability that it is going to be a red?
3 out of 10.
3 out of 10, yes. And what is, just multiply across, 7 times 3. So this is equal to 0.21. Okay. Next is, let's say, letter B. The same, but this time without replacement. So to answer this, the first one is a blue, so that is still 7.
10.
Do you agree?
Fine.
So next, without replacements, let's say we remove the first blue marble. So now what is the probability that the second is a red?
3 out of 9.
Very good. So there are 3 red marbles, and now the remaining marbles here, you only have a total of 9. So it's going to be 3 out of 9. So 7 times 3 is 21 over 90. And that is equal to 0.2333. Okay. So that's a good example. Think about that when you see with replacement and without replacement. Questions? All right, so next one. And this is the last objective for chapter 5. Compute the probability an event occurs at least once. So do you remember? What do you mean by at least once again?
Greater or equal to 1?
Yes, greater than or equal to 1. So if let's say if you talk about at least 2, so greater than or equal to 2. It's always at least is greater than or equal. Okay. All right, and also last time we talked about the complement. What's the complement again?
The opposite?
The opposite. So if I ask you, what's the complement of at least 1?
Less than?
Less than. And meaning, if this is exact, at least 1, so the complement of at least 1 is less than 1, or probability of 0. Do you agree? Yes? So probability of less than 1, a number less than 1 is 0. So think about that, and we're going to need this to solve this type of problems. An example here, example 1. Items are inspected for flaws by 3 inspectors. If a flaw is present, each inspector will detect it with probability 0.8. The inspectors work independently. If an item has a flaw, what is the probability that at least one inspector detects it? So the first thing you're going to do whenever you see this type of problem, at least one, is first you get the complement. So probability inspector fails to detect a flaw. That is 1 minus, remember the complement, 1 minus that probability. So 1 minus 0.8 is equal to 0.2. You always subtract it from 1. Then now to solve for the at least one problem, because that's what we want to solve, is always equal to 1 minus probability of non-detect the flaw. And since we solve it here, the complement of the given, which is 0.2, so 1 minus, since the question again, sorry. At least one, and there are 3 inspectors. So that's why you multiply the complement 3 times 0.2 times 0.2 times 0.2, or simply 1 minus 0.2 raised to 3, and you will get the answer 0.0992. Did you get that? So again, don't get confused. All you have to do is, let's go back here. I'm sorry. So given the probability of 0.8, you want to get a probability at least one inspector detects it. So first get the complement of 0.8. Complement of 0.8 is, you subtract it from 1 is 0.2. Then to subtract, to compute at least 1, that is simply 1 minus complement of this is 0.2. And you are solving with 3 inspectors, so just make it raised to 3. And you will get the answer. Okay? And so take note of that, and let's apply that here. A fair coin toss 5 times. What is the probability that it comes up heads at least once? What is the probability that it comes up heads?
50% or 0.5.
0.5 or 50%. That is correct. And then all you have to get is get the complement of 0.5, which is also 0.5, right?
Correct.
Subtract it from 0.5. And then at least once, so 1 minus 0.5. But here a fair coin is tossed 5 times. So you just have to raise this to 5. So try that. What is the answer?
0.9688.
Yes, 0.9688. Thank you. Okay. So that's the end of chapter 5. And I need to show you examples from the book. So by the way, if you check I already assigned a chapter 6. Since we're gonna finish this on Wednesday, so it's due this Sunday also. There are only 18 problems for chapter 6, 10 problems from 6.1 and 8 problems from 6.2. Okay. Chapter 5. Where is it? Number 39. All right, let's eat. A fast food restaurant chain has 600 outlets in the United States. The following table categorizes them by city population size and location and presents the number of restaurants in each category. A restaurant is to be chosen at random from the 600 to test market a new menu. So you have the regions, Northeast, Southeast, Southwest, and Northwest, and the population under 50,000, 50,000 between 50 and 500,000, and over 500,000. Okay, so I want you to try to read this first and answer it on your own. A, given that the restaurant is located in a city with a population of 500,000, what is the probability that it is in the Northeast?
Uh, 0.25.
How'd you get that?
Just went over to 500, over 500,000, and then Northeast 150 over 600.
No.
No. Okay.
So remember, take note of this. I mentioned earlier, you see the hint, given that. So meaning this is a conditional probability. What did I say whenever you see that hint, given that? Do you remember?
That it becomes the denominator.
Yes, very good. Oops. That's going to be your denominator. So given that with a population over 500,000, What's a population over 500,000? That's a row. So meaning you just have to get the total row over 500,000. So you add 150 plus 25 plus 30 plus 60 is
265.
265. And what's going to be the numerator?
30. 30.
30. Where'd you get 30?
Oh, I'm sorry. I'm sorry. 150.
Yes. So north is, because that is northeast, and over 150,000. So that's why that is your numerator 150. So 150 over 265 is 0.5660. Okay, very good. How about B? So again, is another example. Given that, so do the same thing.
35 over the total of SE.
Say that again.
35 divided by the total of SE, which is 90 plus 25, 150.
Yeah, that is very good. So given that is located in the southeast, so you just have to add all these three. 35, 90 plus 25 is 150. And then what is the probability under 50,000? So under 50,000 and southeast is 35. So the answer, 0.2333. Okay, so letter C, another conditional probability problem.
Okay. For Southwest, 15 plus 70 is 85 over the total of Southwest, which is 85 plus 38. So 85 over 115.
All right, so let's check. But given that it is located in the southwest, so you add that there's a column for southwest, so that is 70 plus 30 plus 15 is 115. And then the question is, what is the probability that's in a city with a population of 500,000 or less? 500,000 or less. So
Oh, 15 plus 70.
and yes, 85.
85.
Yes, that's correct. So 15 and 70, that's within the column of a southwest and less than, both less than 500,000. So that's why you add 70 plus 15 is 85. And 85 over 115 is 0.7391. Very good. D. Given that the restaurant is located in a city with a population of 500,000 or less, what is the probability that it is in the Southwest? So given that a city with a population of 500,000 or less,
So the 85 divided by the total from NE, SE, SW, and W for just the first two under
rows.
500. Yeah, first two rows. Right.
Yes, so you have, so less than 500,000. So these are the two rows less than 500,000. So you just have to add all these numbers. And that is 335. And then you said it is in the Southwest.
85.
So Southwest among these two rows, that is 15 plus 70 is 85. Yes. So the answer is 0.2537. Last one, given that the restaurant is located in the southeast, in the south, meaning southeast or southwest, what is the probability that it is in a city with a population of 50,000 or more? So what do we need to do here?
For the denominator, do you add all of the southeast and southwest together?
Yes. So you have two columns for south, southeast, and southwest. So just add all those numbers. What is the answer?
And the denominator is 25 plus 30. So 55 because they want, oh no, they want 50,000 or more. So it's 90 plus 70 plus 25 plus 30 for the denominator.
The denominator is 265.
265. And the numerator,
Is it 55?
population 50,000 or more.
So do we add the bottom two rows?
50,000 or more. So yeah, so, those,
215,
so 90, 70, 25, 30. So that is, you said 215?
15.
And when you divide that, that is 0.8113. Questions? Right. All right. So another example here. And I want you to try this number 55. every day George buys a lottery ticket. Each ticket has a probability of 0.2 of winning a prize. After 7 days, what is the probability that George has won at least one prize? So I'll give you time. Try this. This is from the last objective for this section. That's the hint, at least one prize with a given probability. So let me know when you have an answer.
I think I got it. Oh, never mind.
See, we have here. Answers. Anahi 0.999, Chelsea 0.7903, Rebecca 0.2097, Michael 35%, Lay Tiffany 0.2097. 0.96. Only one got the correct answer.
I got 0.9999.
It was actually Chelsea got the correct answer. How did you get that?
Since it's at least one, I minus 0.2 from one, so I got 0.8. And then I did 1 minus 0.8 to the 7th degree.
Yes, very good. That's it. So that's why I encircled here a 0.2. So meaning you have to get the complement of 0.2. So 1 minus 0.2 is 0.8. Okay, and use this 0.8 to solve at least one. So 1 minus 0.8. Now it says here 7 days. So that's why this is raised to 7. Okay, so that's why the answer is 0.7903.
Is there an easy way to do the 7th degree on the calculator, or do we just have to do 0.8 times 0.87 times?
Oh no, 1 minus 0.8, the caret sign, right, raised to 7. So look this symbol.
Oh, I see it. Awesome. Thank you.
Yes, yeah, it's instead of 0.87 times, so you have
Yeah.
to.
That's what I had to do.
All right. So that is correct.
Oh, so after she did it to the 7, she minus 1?
Yes, always.
Oh, okay. Got it. Okay.
Okay. All right. Let's try one more for you to remember this. Like 56. So the probability that a certain make of car will need repairs in the first 6 months is 0.3. A dealer sells 5 such cars. What is the probability at least one of them will require repairs in the first 6 months? So this is a problem about at least one. Given a probability 0.3, how do we answer this? Anyone?
Is it 0.8319?
Yes, that is correct. Very good. So how'd you get that?
I did 0.3 minus 1,
Oh,
and then I got
1 minus
0.7, and then I did it to the 5th power, and then I subtracted 1 when I got that.
So the answer is 0.8319.
9. Yeah.
Why is it the 5th power and not the 6th power?
5 cars.
Okay, so the 6 months doesn't play, the 5 cars does.
Because
Got
yeah. So you want please pay attention to the problem. You want the probability of that a certain make of a car. Meaning you're talking about the car here,
Gotcha. Okay, that makes sense.
about not the months. So you're talking about the cars. So that's why 5 cars. So raise it to 5. Okay. Any questions about chapter 5?